By the end of this lesson, we will be able to solve equations that have variables in the denominator. We will use the multiplication property of equality to clear the denominators and then solve. Okay, for the warm-up, we have two problems. Part A wants to know what is 5 divided by 0. Sometimes these simple ones can be confusing. So let's check our calculator. I'm not sure if it's 0. Let's see. If I do 5 divided by 0, it gives me this error message, divide by 0. So let's quit by hitting enter, and let's think about what does this mean. 5 divided by 0. If I had 5 items, can I divide them into groups of 0? It's impossible, so there's actually no solution. I can even say it's empty. Okay, the next one. 20 divided by 0. If I had 20 students in a class, could I divide them into groups of 0? No. Again, if I try 20 divided by 0, the calculator should generate the same error message, which it does. So here, we're going to write no solution as well. I can also use the null set symbol. Both of these examples are undefined expressions. An expression is undefined when the denominator equals 0. This is a special name we give to any fraction when its denominator simplifies to be 0. It specifically refers to the fractions with a denominator of 0 because we cannot divide by 0. So going forward with today's lesson, we plan to exclude x values that will turn the denominator into 0. Okay, example 1. What values for x will make this expression undefined? Well, we just learned that undefined means when the denominator is equal to 0. So when the denominator is equal to 0, that would be when, instead of the denominator, I can say when x equals 0 here. This expression would be undefined. So now let's take a look at example 2. It says what value or values for x will make this expression undefined. So now I want to say when this denominator, x plus 5, is equal to 0, the expression will be undefined. So now the question is, what value would go here for x to make this true? Hopefully you're thinking when x is equal to negative 5, the expression 10 over x plus 5 is undefined. This is true because if I were to solve this equation right here for when the denominator equals 0, I would see that when x is equal to negative 5, if I put negative 5 in here in the denominator, I'll end up with 0. And now this expression is undefined. We would not be able to divide 10 by 0. Technically, I could place any other real number here for x, and I would still be able to find a quotient. So let's look at example 3. Again, it wants to know what number or numbers cannot be here for x because it will turn the entire denominator into 0. Notice we haven't cared about the numerators. So we want to know when will this denominator, 3x minus 6, equal 0. If you cannot predict the value, you can solve this equation to find it. If I add 6 to both sides, it's when 3x is equal to 6. When I divide by 3, I realize when x is 2. So let's see what happens. If I plug in 2 for x, my denominator ends up being 6 minus 6, which is 0. We cannot have that. So when x is equal to 2, the expression x minus 4 over 3x minus 6 is considered undefined. It has no value due to a denominator of 0. Again, I can have x in this expression be any other real number except for 2, because 0 is the only number we can never divide by. Next, we want to focus on solving equations that have a variable in the denominator. We'll revisit why undefined was so important. We'll get back to that later. But first, let's fill in our steps. Step 1, we want to state the excluded values that would lead to a denominator of 0. It's important to be aware of the values that must be excluded. We cannot have a denominator of 0 because then the expression would be undefined and have no solution. So it's good to be mindful of these values at the beginning. Then we want to solve the equation. But these equations are going to look different than ones we've seen previously in class. So our goal is we want to get rid of the denominator. Okay, we normally haven't had denominators before that involved a variable. To get rid of a denominator, we can multiply every term on both sides by the denominator. Hopefully this should be familiar. If I want to get rid of a denominator, remember denominators are attached by division. So the inverse would be to multiply. This is technically using our multiplication property of equality. We are allowed to multiply an equation by any value on both sides as long as it's the same value, and it's done to every term on each side. Okay, let's check out example 4. Our first step is we're supposed to state any values that should be excluded because they lead to a denominator of 0. So looking at this equation here, I notice that the left side could certainly be undefined when x is 0. So I have to state at the beginning that I know x is not allowed to be 0. That cannot possibly be a solution. 30 divided by 0 would be undefined. So it definitely could not give a solution of 5. Now, most of us know what our value would be here. 30 divided by 6 would give us 5. Let me show the work on how to use properties of equality to solve. For step 2, we want to solve for x. Our goal is to get rid of the denominator by multiplying every term on both sides by that denominator. So here, our denominator is x. Multiplication property of equality says it. If I want to multiply by x on the left side, I have to multiply it by x on the right side. And our solution will still be true. We'll still keep the same solution. So now let's see what we end up with. I would end up with 30x over x equals 5x, which looks a little complicated, but hopefully you remember x divided by x, they reduce to 1. So I really have 30 times 1. So if 30 is equivalent to 5x, we will get the solution that we were anticipating in the beginning. When we divide both sides by 5, we find x is equal to 6. So my solution is 6, which this value is allowed because it was not excluded in step 1. Okay, now example 5 is not as obvious as example 4 for some of us. It's saying that some number is divided by a number that's a little bit larger. It's larger by exactly 3. If I find their quotient, I should end up with 5. Now, of course, we could try trial and error, but there's always a mathematical way to solve the problem. So for step 1, let's state any values that should be excluded because they would lead to a denominator of 0. Here, for x, I cannot have negative 3. If I had negative 3 plus 3 in the denominator, I would end up with a denominator of 0. So at the beginning, I want to remind myself that my solution is not allowed to equal negative 3. Okay, so now step 2. Let's solve the equation for x. We need to get rid of this denominator. Remember, algebra is kind of a story of numbers. So this x is saying it's just plain old x, some unknown number. But then the story is I have to divide it by a different number. This number that I'm dividing by is 3 larger than x. It's just x plus 3. That's the story. It's some number that's larger than x by 3. So if I want to get rid of this number, I can't only multiply by x. I have to multiply by that entire number, x plus 3. Whatever I do to one side, I must do to the other side. There's my wall. Now, x plus 3 divided by itself would give me 1. I'm left with 1x. Remember, the reason we multiply by the denominator is to get rid of it. But now on this side, I still have 5 times x plus 3. Now I must use the distributive property of x equals 5x plus 15. Next step, subtract 5x from both sides. We want to keep all of our x terms on one side of the equation. I chose the left side. So if I have 1x minus 5, I end up with negative 4x equals 15. Let's continue this wall. Okay. Now, final step, divide by negative 4. And I end up with x equals 15 over negative 4, which I cannot reduce. It is equivalent to a decimal, but leaving our answers in fraction form is fine. So my solution, my only solution, is 15 over negative 4. For any of us that are still a little confused or not convinced, let's check this answer using our calculator. So if I type in 15 divided by negative 4, I find that the decimal equivalent is negative 3.75. So now the original equation stated that that number divided by itself plus 3 should give us 5. Let's check it out. Let's do negative 3.75 divided by, now it's not divided by itself, it's divided by, in parentheses, itself, negative 3.75 plus 3 more. I have to close it. Now the calculator will follow PEMDAS. It'll evaluate this denominator, which is negative 0.75, and it will then divide. And we will end up with 5. So we have found the correct answer. Okay, example 6 is harder than the previous examples so far. Hopefully you notice right away it has 2 denominators and they're different. So first step, we still have to state any excluded values. On the left side, x is not allowed to be 0, but on the right side, if I have an x value of 2, 2 minus 2 would make that denominator 0. So I have to exclude 2 different values for this problem. All right, now let's solve. We want to get rid of both denominators, but we have to take care of them one at a time. Let's start with getting rid of x. If I multiply this side by x, these will reduce to 1. But whatever I do to one side, I must do to the other. So now I have 1 equals 3 times x is 3x up top over, because this is over 1, we end up with x minus 2 still in the denominator on the right side. Now let's get rid of this denominator. I must multiply by x minus 2. Remember, it's just a story. It's saying it's that x value minus 2, so it's a smaller number than x. But whatever I multiply on the left side, I must multiply on the right side. I think I said that backwards, but as long as I multiply by the same amount on each side, I'm following my multiplication property of equality. Okay, let's see. X minus 2 and x minus 2 will divide with itself to give me 1. So I'm left with 3x over 1, or just 3x, equals, let's distribute this in, x minus 2. Now we're back to some of the multi-step equations we should be more familiar with. I see x on the left and the right. I have to pick a side, so I'm going to subtract x over. I now have negative 2 equals, well, 3x minus 1x is 2x. Our final step will be to divide both sides by 2. We want x to be totally alone. So now we have negative 1 equals x. So I go back up. I see that x was not allowed to be 0 or 2, which means negative 1 is an appropriate solution and my only solution. For those of us that are looking for a reward on a green ticket tomorrow, just remember that my favorite flavor of ice cream is fish food from Ben & Jerry's. Remember, fish food, yes, like the fish in an aquarium, fish food. Okay, let's take a look at number 7. At this point, I'd like for you to pause the video and try to eliminate the denominator on your own, and then press play to check and see if you did it correctly. Okay, let's see how you're doing so far. First, looking at the original problem, you should state that x is not allowed to be 2. 2 minus 2 would create a denominator of 0 on both sides of this equation. Next up, we have to try to solve. So to get rid of this denominator, I chose to multiply by it. X minus 2 will reduce with itself. But what's pretty cool about this problem is on the right side, the same thing will happen. So now I'm left with just my numerators, which should make sense. If this fraction had the same denominator as the right side, that means that the numerator should be equal if I want the equation to be true. So now if I subtract 3 from both sides, I find out x is equal to 2. But wait, is 2 allowed to be my solution? Let's check it out if we plug it in. If I try to substitute into my original equation, x minus 2, x minus 2, I would end up with over, let's see, if I plug in 2, I would have 2 plus 3 over 2 minus 2 should equal 5 over 2 minus 2. Am I allowed to have something that's 5 divided by 0? No, this is undefined. So now I have to actually reject this answer and state that there is no solution. We cannot have an undefined value within an equation. Now you should be prepared to be able to solve equations that include variables in the denominator. Tomorrow we will practice this skill in class using our multiplication property of equality to clear the denominators. Thank you for watching.